Welcome to the video for C5.2.3, where we're going to look at the effects of concentration and pressure on rate. So first of all, I want you to pause the video and try and write a definition for reaction time and reaction rate. So hopefully you've written something along these lines. So the reaction time is the time that it takes for all the reactants or the starting materials to be turned into the products. So it's the time it takes for the reaction to finish. The rate of reaction is when we're measuring the change in the amount of product formed over a given period of time. So here's our learning objectives for today. We need to be able to describe and explain the effect of changing the pressure when we've got a reaction that involves gases and changing the concentration when we've got a reaction that involves solutions. So we're going to look at gases first. So we need to know what low and high pressure means for gases. So for these two cylinders have the same volume. So for the low pressure, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 particles of gas in that container. And this on the high pressure, we've got the same one. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I've got 17 particles. So it doesn't matter the exact number. The point is that the high pressure has got more particles. But we need to be clear when we're writing this in an exam that it's not just more particles, because I could have, so say I've got this size with 8 particles, so that's the same as this one here. If I had a bigger container but the same pressure as that, so say it was twice the size, I might have 8 there and 8 there, so I'd have 16 in total. So we need to be specific that it's more particles in the same volume. So I've put that in bold there because it's really important. And because you've got more particles in the same volume, that means that they've got more frequent collisions. So again, that word's in bold because we need to use that in an exam. So the best way to think about this is that if it's more crowded, there's going to be more frequent collisions. So if we think about our classroom and the size of our classroom, if I got you all to walk around our classroom, you could probably do it without bumping into each other. If I open the door between me and the next lab and I'll let the next class come in and there's twice as many people in there, then it's more likely that you're going to get collisions. You're going to get more frequent collisions because it's more crowded. Okay, so solutions is the same, except then we're talking about concentration rather than pressure. So, but it's exactly the same argument. So these pictures show what looks a bit like some blackcurrant squash. So if something's dilute, then if it's something that's coloured, it's going to be pale, and if it's concentrated, it's going to be darker. And that's because there's more particles when it's concentrated. So these two diagrams here, so this is low concentration and this is high concentration, and you'll see it's exactly the same as the diagrams that we had for the pressure, in that the low concentration I've got less particles in the same volume, and in the high concentration I've got more particles, and again we need to be specific that it's more particles in the same volume. And once again, because there's more particles in the same volume, you're going to get more frequent collisions. Okay, so here's a possible experiment that we can do. So if we take magnesium and we react it with hydrochloric acid, then we make magnesium chloride and hydrogen gas. So because this is a gas, we can measure the volume of this to follow the rate of reaction. So here's some example results that we might have had. So we've changed the concentration of the acid. So here the concentration of the acid has increased. And as we've done that, the reaction time has gone down. And because the time's gone down, so remember if we think back to our first slide, so if the time's gone down, the reaction's got faster, and that means that the rate of reaction has increased. So our rate has increased. And that's what we would expect, because as we said, as we increase the concentration, we've got more particles in the same volume. So therefore, we've got more frequent collisions. So I want you to do two things. First of all, I want you to plot a graph of these results. You've got some graph paper. And secondly, describe and explain the trend. So describe just means we're saying so we're just linking our two variables here. Sorry, my pen's gone a bit funny. So we're always writing as the something either increases or decreases, the something else increases or decreases. Okay, and then the explain is going back to our collision theory idea. So we need to explain it in terms of the frequency of collisions, but we need to be specific about what's colliding. So in this case, it's the collisions between the magnesium and the HCl collisions. Okay, so pause the video and have a go at that, and then we'll write it out properly. Okay, so hopefully we've written that as the concentration of the acid increases, the rate increases. Okay, and then to explain that, this is because as the concentration of the acid increases, there are more acid. I'm going to underline that because we need to be specific about the particles. There are more acid particles in the same volume. This means there will be more frequent collisions between the acid and the acid particles and the magnesium particles. So it's good practice to write what it is that is colliding, because there's not always a mark for that, but sometimes you lose a mark if you don't do that. Okay, so what we should have is a graph that looks like this. So we should have a nice, smooth, continuous line for our curve. Okay, so here's an exam question for you to have a go at. So increasing the concentration of a reactant in solution will increase the rate of reaction. Use the reaction particle model to explain why. Okay, so pause the video and have a go at writing this. Okay, so hopefully we've got this idea of either the particles are more crowded, the particles are closer together, more particles in the same volume. So this is the one that I prefer. More particles per unit volume, and therefore more frequent collisions.